with the recent release of RTX64 2013 with Service Pack 1, we've provided a lot of new functionality based on customer feedback. The purpose of this training video and these slides are to go over those features and give people an idea of what's been implemented in this service pack along with known issues. So if we just start at the beginning with the installation of the product, we see that we've added some prerequisites. So we now, with this release of the product, check for .NET 4.0. With the previous release, we would actually have customers install the .NET framework themselves before they could install RTX 64. We've also added the inclusion of the dongle support. So with the previous release of the product, if somebody was going to use dongles for their licensing, they would actually need to install the SafeNet dongle driver. With this release, we actually install the dongle driver for you, so you don't have to worry about that piece. If you've got the SDK, the RTX 64 SDK, we do checking for the Visual Studios that we support. So Visual Studio 2010 and also Visual Studio 2012. If they're found on the machine, we'll provide options during the installation for you to select those components. So if we look at upgrading of RTX 64 2013 to Service Pack 1, you can see that we've got some previous releases already out in the world. There's the base release of the product, and then there's the update 1 we provided. We've also provided a number of RC builds to customers to have them test functionality. So with this, you can see that we provide upgrade support for the base version of the product. We also provide upgrade support for update 1. However, the RC builds that are out, they can't be upgraded. So what we've recommended to customers is to have them uninstall the builds that they have on their machine before they install this Service Pack 1. Now, unfortunately, with these upgrades, we don't save your configuration. So if you've made changes to the subsystem, such as HAL timer period or watchdog timer, those settings will not be saved, so you'll have to reconfigure your machine after you install the Service Pack 1. We've also had to make some changes to how we handle device conversion, which we'll go into later. But because of this, if you have any devices converted to RTX 64 with previous releases, you'll have to convert those devices back to Windows before you install this version with Service Pack 1, and you'll have to reconvert the devices to RTX 64. So we've also made a couple changes to licensing with this release. We've upgraded to the latest version of our third-party licensing system, which is Reprise. And one of the reasons we did this is because we had a problem with dongles. So if you plugged in a dongle other than a Reprise dongle, it would sometimes the licensing would be confused and you wouldn't be able to properly license the product. The upgrade, the 9.4 version of Reprise takes care of this issue. We also added an improved API call, RT Get License feature, status EX. This allows third parties that are using our licensing system to check for their product codes. It also allows them to get additional information about the product code for options if they're using that piece within our licensing system. We also have a known issue. Currently, if there are too many licenses, so if you have a large number of components licensed within the product, the licensing may not be recognized. This is a known issue. Currently, all our default bundles that we provide for SDKs, runtimes, Acontis bundles work without any problem, but it is something that we're keeping an eye on in case we do add additional add-on components which require new licensing, which may cause a problem. But right now we're set and the current bundles work. So let's take a look at the control panel. With the Service Pack 1 release of RTX 64 2013, we've added control panel functionality, which is integrated into the Microsoft control panel. So if you go into the Microsoft control panel area, you'll see that you can actually search for functionality for RTX 64 pieces such as HAL timer period. You can also see that we've reordered how we talk about things in the control panel so that they're more task-based. So hopefully it's more user-friendly and easier for customers to find features within the the control panel. So if we look at the main screen of the control panel, you can see that we've got all the key areas in here, so it's sort of a one-stop area for people to find what they're looking for. So we've got activation and configuration information here. We provide access to the user groups. You can configure the subsystem, manage devices, configure the TCP/IP stack. We also provide information about what components of the product have been licensed, and you can see that the license information is provided up here, as well as version information is provided. If we look at sort of some of the caveats with the control panel, we have an issue with the groups. With the 64-bit product, we create 3 user groups, Windows user groups for customers. There's an RTX64 admin, an RTX64 debugger, and an RTX64 user. Unfortunately, we didn't get all the features sort of nailed down with that, so for this release you actually have to be a Windows admin and an RTX64 admin to use the control panel. And we do a check at the startup of the control panel, so the customer won't get any error messages when they try to use it. We also have had issues with notifications not popping up correctly. So on configuration of the HAL timer period, you might not get the proper pop-up message that you need to restart the subsystem, or you may that message may continue and not be removed until you actually close and reopen the control panel. We also have found issues where the fields don't always refresh. So the control panel was implemented with WPF, so this is a new Windows technology, so there are some bugs in WPF itself, and this is one of the issues we found with that, where if you make a change to a field, it doesn't always refresh itself right away. So one of the issues we had with the RTX64 product, and actually the RTX product as well, is that when our logic was enabled to prevent Windows speed step by preventing the C1 idle state and by also preventing the Windows idle threads from running, it caused Windows not to load balance. So after some investigation and talking to Microsoft, we've actually changed our implementation there. So there is actually no functionality that the user has to change in the control panel. It's all done in the installation of RTX64. So functionality that you've seen before in the previous command line utility is no longer available. So there was a prevent C1 idle state and prevent Windows idle threads. That functionality is gone. Unfortunately, it's still in the command line utility, but those fields do not do anything now. So if for some reason a customer would actually call them to enable them, they wouldn't have any effect on the system. So if we look at the watchdog timer, in the previous release of RTX64, we had an issue where the watchdog timer functionality was not being properly enabled. We've resolved that in this release. However, based on some issues we found with the configuring and starting and stopping of the TCP/IP stack, the watchdog timer functionality is disabled by default, because when you hit the watchdog timer timeout, it freezes all RTSS processes on the machine. The TCP/IP stack is actually an RTSS process. And so when that gets frozen and you try to kill that process, that can lead to blue screens or green screens. So right now, if the watchdog timer goes off and all the processes are frozen, your only option really is to reboot the machine. So with Service Pack 1 of the product, we've also corrected issues that we found with our local memory. With the previous releases, there would be random blue screens or green screens when you were using local memory, so we had actually sent out a notice to customers saying that they should not use local memory with the release out there. With this release, local memory has been fixed. As part of that, we've created a new area in the control panel for setting up the requesting from Windows or from our local memory pool. We've also added functionality, so in addition to being able to auto expand or disable auto expand, you can now disable shrinking of memory. By default, the auto shrinking is enabled. This would be a functionality that you would want to turn off if you know that you're going to use that memory again and you don't want the subsystem to to shrink on you. We've also provided API calls for this, so you can, within your application, expand memory or shrink it with the API call you can see here. And we've also added an RT allocate local memory EX. This function was provided because by working with one of our customers, we found that large memory allocations were actually much slower than in RTX64 than they were in Windows. We tracked that down to actually zeroing out the memory. So with this RT allocate local memory EX, you can set a flag to say don't zero out the memory. This allows us to be much faster in larger memory allocations than we previously were. So one of the areas that has changed between Service Pack 1 and the previous releases is the device conversion. With previous releases of the product, we had the RTX64 config command line utility that you could use to convert devices to RTX or convert them back to Windows. With this release, we're actually using the Windows standard behavior of the device manager. So as part of this, we've provided an out-of-the-box INF file that contains all the devices we support. Currently right now it's just a list of all the NICs that are supported in RTX64. This is an area that we're going to need to expand upon as we support more drivers. We'll have to provide a newer version of the INF file. But for right now, it's a list of all the supported NICs we have. So with this, you would go into the Windows Device Manager, you would select a device that's listed, and you would just do an update driver on it, and you would select the RTX PNP driver. So you'll also see here that if you look at properties of a device, we've created an RTX64 tab. So this is functionality that you should be familiar with if you've used the RTX product, where you can set the IRQ information for the device. Okay, so one of the caveats of this is that with new devices that we don't support out of the box, the customer is going to have to create an INF file that they sign. So this INF file will contain the hardware ID for the device, and when they digitally sign it, that will allow them to convert it to RTX. We do have a template in our SDK documentation that explains how you would create an INF file and how you would sign it. And you'll also see that the functionality we previously had for the RTX64 config, the convert to RTX, does no longer work. And the reason that this doesn't work is because of Windows 8. Another area that we've improved upon is the RT TCP/IP stack. So we've added functionality within the control panel to allow for easier interface creation within our stack. There's no more INI file like there was in the RTX product. So with this interface, you can select the device, and when you select the device, we'll make a best effort to find a default driver if one exists for the device. So for example, this 82571, it's the RTE1000 driver that we provide, so it's pre-selected for you. We also fill in the location information, so you don't have to look around in the device manager to find the appropriate location if you've got multiple NIC cards in your machine. However, there is one caveat here that friendly names, which are used to distinguish the different interfaces, can only be 14 characters with this release. This is something that we'll fix in a future release. So let's take a look at the RT TCP/IP drivers that have been provided with this Service Pack 1. We've provided an RT-IGB driver. This driver contains support for the Intel i210 NIC card. We've also provided a version of this driver outside of the released product, which supports the i350. So this driver contains device IDs for just the drivers we've tested. We haven't provided the device IDs for additional cards at this time. We'll add cards in future releases. So there's also, with the NIC drivers, we've found that multiple applications cannot load a NIC driver at the same time. So we've had a couple customers run into an issue where they were using our provided network drivers outside of the TCP/IP stack and also using the TCP/IP stack. Based on how the drivers are currently implemented using critical sections, this functionality is not supported. Customers have done workarounds by changing the critical sections to to mutexes or other locking logic to allow for this, but with this current release, it's not supported. Let's take a look at the RTX64 RT TCP/IP stack. Unlike the RTX product, this product is based on a different TCP/IP stack. It's based off a third-party TCP/IP stack from Trek. While running tests on the stack, we've noticed some issues in some areas that we just want to bring to people's attention. So one of those areas is that the stack does not handle link status properly. So what this means is that if you unplug your cable from a NIC card, the stack does not clean up the packets correctly. So what can happen is the buffers fill up and then the stack may crash. Other issues we found is with our NIC drivers and with multiple interfaces. So under certain drivers, so the 8168 or the RTE 1000 in combination with the 8168, with the multiple interfaces, we've seen inconsistent packets coming in. So you may see inconsistent behavior, and you may also see a crashing of the TCP/IP stack. Okay, so now on to the real-time kernel functionality. This is functionality that we had a number of customers request, so we added it in with Service Pack 1. As you can see from this diagram, it's an updated one of the one we've had before. We've added in this this box right here. So what the RTK allows you to do is it allows you to have a Windows driver and have that driver communicate with the RTX64 subsystem. Okay. So if you can see here, so we've got an RTK API.h, which is the header file, and we've got a lib file that you would link into your Windows driver. So it provides functionality for mutexes, events, semaphores, and shared memory. So you can do pretty much all the IPC functionality that you could do between a Windows user level application and RTX64. You can now do that in a kernel driver. So the one difference here is that everything needs to be called at passive level, and then we've also provided a sample for you. It's RTK IPC is a sample that shows you how you would write a Windows driver that uses this functionality. One of the differences here that people should be aware of is that we've modified the API calls between the RTX product and the RTX64. The API calls now are more similar to what a kernel driver writer would expect, whereas the call is passing back an NT status versus that information being passed back in a parameter. So that's a difference, and people that are porting code forward to RTX64 will need to make some modifications to their code so that they are passing back the right information. Well, are receiving the right information back. Okay. So some of the issues, other issues that we've resolved in the product is RTAPI error returns. We had an issue with the base release and update 1 where RTAPI API calls, which are the calls within the Windows application linked to RTX64, were not always being returned back the proper error code. So that's something we fixed in this release. So now that we're returning the information back correctly internally, we still need to go back through and make sure that those error codes are the proper error code, and then they match up with what you would expect to see from a Windows application making the same call. We also need to just do some additional testing to make sure that we have no race conditions and how that error information is being passed back. And we haven't seen any of that in testing wise, but just based on reviewing the code, it looks like there's a potential for some race conditions there, so we want to make sure that we don't have any issues. So let's move on to new API calls. With Service Pack 1, we provided a couple new API calls for people to use. We've provided some query performance calls. These calls allow for customers to do better comparisons between Windows performance and RTX64 application performance. We've also provided wait for single object EX calls. These calls allow you to have a finer granularity with the time you wait for objects. This is a functionality that was requested by a couple of customers and was actually in an update to RTX 2012. So we've ported this functionality to the RTX64 product. Another key feature we've added with this Service Pack 1 has been Visual Studio 2012 build support. That support includes an application wizard for Visual Studio 2012. The application wizard allows you to pick key functionality through templates we provide, so events or timer threads. It also creates the configurations you would need to build your application. So there's 4 configurations that are provided. They're all 64-bit configurations. So we've got RTSS release and debug and a Windows release and debug. We also provide documentation for how to build 32-bit Windows applications linked to RTX64. We provide a new macro RTX64 platform. This was provided because we noticed on some machines, based on how Visual Studio was installed, that the Windows platform macro would default to either x64 or x86, and it would lead to inconsistencies in the build. We've also provided support for the Visual Studio 2012 C runtime. So once again, we're no longer modifying the Microsoft C runtime. So it's the C runtime that comes with Visual Studio 2012. And we support the release and debug versions. One of the caveats of supporting the C runtime without making any modifications is that it uses a much larger amount of memory. So we've actually upped the size of our thread stack. So it's now 8 pages. And then also Visual Studio 2012 no longer supports makefiles. So we haven't made any modifications to RTX64.make to support Visual Studio 2012. Okay, so one of the other areas that we've made some efforts in is our samples. We've gotten a lot of feedback that customers would like to see more samples, or at least more documentation around the samples. So we've done some restructuring of the samples so that there's Visual Studio 2010 and 2012 projects to build all of them. We've also provided some new samples. So we've got a ping pong sample, which is 2 threads communicating between each other with events. We've got a simple data exchange, which is showing shared memory usage. We've got a mailbox, which shows how you would create your own mailbox logic if you wanted to. And then there's a sample for Windows and RTX using standard template library. So with our samples, we've done a lot of work to improve them, but there's additional work we could do and will be doing in the future releases. So we do need to do some coding improvements there just to make sure that everything is documented and easier for customers to understand what we're trying to show them. We also right now don't have any samples that use the Intel compiler. So it's documented in our documentation how you would configure a project to use the Intel compiler, but we want to offer a sample to show that. And we also want to make sure that everything is documented fully so that people understand what the header files and C files are for, and how to run them, and what they expect to see as the resulting behavior. Service Pack 1 also contains support for Windows 8. At the time of QA and testing of this product, Windows 8.1 had not been officially released yet, so all our testing has been done on Windows 8, and so we officially claim support for Windows 8, not Windows 8.1. The majority of our customers are on Windows 7, so we haven't made a strong effort to fit into the Windows 8 look and feel. We've tested on the basic Windows 8, and we've tested on Windows Embedded Standard 8, and we do provide updated documentation to explain how you would integrate your Windows, your WES 8 embedded to include RTX64. We do have one caveat with Windows 8 on newer machines, usually Generation 4 machines that support X2 APIC. RTX64 does not work. This is something that we'll fix in a future release, but right now on newer Gen 4 machines, Windows 8 will not work with RTX64. And lastly, the RTX64 latency view tool that we provided as a standalone post update 1 has now been included into the RTX64 2013 SP1 release. So the latency view is part of the standard runtime product, and it's an optional feature, so if you don't want to include it, you don't need to. We're not providing the source for it, but if a customer was interested, it's definitely something that we could provide to customers to show how you could write a managed application that communicates with RTX 64. This concludes the RTX 64 2013 Service Pack 1 presentation. Thanks for watching.